Okay, so we'll finish off on partial fractions. So remember, the way that we would do it is if your denominator has linear factors, then you would split it up, for example, like this. So you have some function, we'll just call it f of x, and then in the denominator you'd have a linear term, so this is linear 1 and this is linear 2. Okay, and then you would rewrite this as a over the first one plus a over, b over the second one. Okay, here we had no repetitions. That means the exponents over here were 1. Then you could also have where some, they're all linear, but some are repeated. So you have L1 the power of 2, for example, and here I have L2, and we say that the numerators are still constant terms. So you have A over L1, but then this time you build up to it B over L1 squared, and then you have C over L2. And then when you have not repeated, when you have irreducible quadratic, so for example you have f of x, and then here let me just say this is x plus 1, and here I have x squared plus 1. Now even if it's squared over here, the procedure is still the same. What I will do is I will rewrite this as a over x plus 1 plus bx plus c over x squared plus 1, and then I will say plus dx plus c over x squared plus 1. Okay, so notice I'm doing the same thing and building up to this x squared plus 1 squared. So if my exponent over here was 3, I would have x squared plus 1, then x squared plus 1 squared, x squared plus 1 cubed, and so on. Okay, so it's not different than when I had repeated linear terms. Then the last one I want to look at today is the one that I kept mentioning, but we never did an example, is when you have something like this. You have x cubed minus x minus 2 over x squared minus 1. Now here what you'll notice is that the degree of the denominator is less than the degree of the numerator. So here my degree is 2, and over there the degree is 3. So what you have to do is first perform long division. So you know how to do long division. So here I put x squared minus 1, and then I put x cubed minus x minus 2. Then the way we'd always do it, say x cubed divided by the x squared, I get x, so I write it there, and then I multiply the x with all the terms that I have over there. So x squared times x, I get x cubed, and then minus x times x, this is minus x, and then I subtract. X squared, x cubed minus x cubed is 0, negative x minus negative x is 0, and then minus 2 minus 0 is just minus 2. Then when I have a term over here that is less, whose degree is less than what I have over here, this is my remainder. So on top over here I have x, just to write it nicely, just draw a line to separate. Then what I can do is I can rewrite this x cubed minus x minus 2 over x squared minus 1. this is just equal to x minus 2 over x squared minus 1. So I have rewritten it from here, where I have a numerator whose degree is higher than the denominator, to here, where the degree of the denominator is greater than the degree of the numerator. Then what I will do is I will decompose this part here into its partial fractions, and then my final answer I will just include the x over there. Okay, so let me do that. So I have 2 over x squared minus 1. Now the denominator can be factorized using the difference of squares. So I have 2 over x minus 1 over x plus 1. This is equal to a x, going too fast, it's a over x minus 1. Let me put it a over x plus 1 plus b over x minus 1. Okay, so that's what I have. Then I combine the two and then look at my numerators. So I will have a times x minus 1 plus b times x plus 1. And this must be equal to the numerator I have, which is 2. So this should be equal to 2. Okay, then I say let x equal to 1. Now if x is equal to 1, you'll notice that the a will disappear. Then I will just have b left. So when x is equal to 1, I have b times 2 is equal to 2. And this means that b is equal to 1. Okay, then I could also let x equal to minus 1. And again, you will see that if x, let me just write this better. Now you'll see that if x is equal to minus 1, the b will disappear. And then I will be left with a alone. Okay, so I have a minus 1, this is minus 2, and this is equal to 2, and this means that a is equal to minus 1. So I have my values of a and b, minus 1 and 1, so I will substitute them over here. So a is minus 1 and b is positive 1. So remember what I have to write the whole equation, the whole fraction. So I started with this, said x to the power of 3 minus x minus 2 over x minus 1. We say this is equal to the x that we got from long division, and then I was subtracting. Now this one I will put it in brackets because I am subtracting the whole fraction, the sum of the two fractions, not just the first one. So it's minus a, we said it's minus 1 over x plus 1, and then plus b, which is 1 over x plus 1. Okay, this is all in brackets. It doesn't look so nice, but that is what it is. So here, then I can remove the brackets. When I decompose it, I have x plus 1 over x plus 1, and then minus 1 over, this is minus x minus 1. Okay, so this is my decomposition, and we did this by first using long division. The reason we use long division is because the degree of the denominator was less than the degree of the numerator. So we only go straight away into your A, B, and C if the degree of the denominator is greater than that of the numerator. If it is equal to or it is less than, then first you must do long division and then you may proceed. Okay, let's look at another example. We have x squared over x minus 1 squared. Okay, now in this case, the degree of the numerator and the denominator are equal, so I will still have to do long division. The only time you do not do long division is when the numerator's degree is less than the denominator. If they're equal, you must first do long division. Okay, so our long division, first I must multiply out the brackets in the denominator. So I'll have x squared minus 2x plus 1. Okay, then long division, you know how to do it. I put x squared minus 2x plus 1. This goes over there, and then I will put x squared over there. So the procedure is not different. I will always say this divided by the first term. I write my answer up here, then I multiply, write it over there. The term I wrote there multiplies this one, it multiplies that one. So the procedure is the same. It doesn't matter that now I have a quadratic expression over there. So first one, x squared divided by x squared. My answer is 1. And then I multiply everything by 1. So I get x squared minus 2x plus 1. And then I subtract. X squared minus x squared is 0. And then over here, I have 0x plus 0. So 0x minus negative 2x, this is just 2x. And then 0 minus positive 1, this is minus 1. So I will stop here because the degree of this expression over there is less than what I am dividing by. So this is my remainder. 2x plus 1 is my remainder. So this x squared over x minus 1 squared, this is equal to 1 plus 2x minus 1 over x minus 1 squared. Okay, now my degree over here, the numerator is less than in the denominator, then I can proceed with decomposing. Okay, so I'll write it in a different color. So I have 2x minus 1 over x minus 1 squared. So this is linear, but they are repeated. So this, when I decompose it, I will have a over x minus 1 plus b over x minus 1 squared. Okay, because it's repeated. It's linear but repeated. It's not quadratic. Then I will multiply this part out, or combine the two fractions and look at my numerator. So I have a, so I'm looking at my numerators now. So I have a times x minus 1 plus b. This is equal to 2x minus 1. Okay. And I see that when I substitute x is equal to 1, the a will disappear. So I can say let x equal to 1. Then if x is equal to 1, then I have b is equal to 2 times 1 minus 1. This is just equal to 1. Okay, so I have b is equal to 1. That is the first one. And then for the second one, to solve for a, there isn't a number that I can substitute to get rid of b. So what I can just do is let x equal to 0. You can say let x equal to 0. Then I will have a times minus 1 plus b. This is equal to 2 times 0, which is 0 minus 1. This is just minus 1. So I have minus a plus b is equal to minus 1. But I know what b is. B is equal to 1. So I have minus a plus 1. This is equal to minus 1. This means that minus a is equal to minus 2, and therefore a is equal to 2. So I have my values of a and b. Then I will go back and substitute them over there. Okay, so I can rewrite the whole expression. So this is what I started with, x squared over x minus 1 squared. And when you decompose this into the partial fractions, what I get is 1 that I got from the long division, plus a, which is 2 over x minus 1, and then b, which is 1 over x minus 1 squared. Okay, so it's always good to check by combining the three terms. So you combine this, that one, and see if you end up with what you started with. If not, then you need to check your calculations. Okay, then that is it on partial fractions. I sent you the notes on the binomial theorem. It's a pretty short chapter, and I think we can cover it in this lesson because there are two main things that we look at. The first one is Pascal's triangle, and then the second one is the actual binomials theorem itself. So this is the chapter on binomial theorem. Oh, by the way, the test is at 6 p.m. tomorrow, because I think you said Wednesday, and you need a scanning app. Okay, so it'll cover the same content as is given in the course outline. What test 2 was supposed to cover, that is exactly what it will cover. So look at the course outline there, and then that is what it will cover. So 6 p.m. you'll maybe have, I don't know, 90 minutes for the test, and then you must send the scanned test copy back within a certain period of time. So it must be on time. So when I look at my emails, I must see that the test came in before the time was up. So do not say I have enough time, I'll just send it whenever. No, it's still a timed test, except you're timing yourself now. Okay, let us continue. Now with the binomial theorem, what we are doing is basically expanding binomials. Now binomials look like this. You have a plus b, and then we raise it to an exponent, and then we want to expand it. Now, with small numbers, when n is a very small number, it's not difficult to do. For example, if I give you a plus b to the power of 2, this one, you know it's just a plus b, and then you multiply it by a plus b, and then you know the rule that the a must multiply everything in the next bracket, the b must multiply everything in the second bracket. So that's not difficult. Now what happens when we have bigger numbers? Let's say I give you this a plus b to the power of 10. Now this one, you can do it that way, but it'll take you quite a long time because you must write 10 of those brackets. So you say a plus b, and then you must have 10 of the brackets a plus b, And then to work it out, you must multiply the first two, get an answer, multiply with the third one, get an answer, the fourth one, get an answer, and so on, which will take you a long time. So what we use to work out these binomial expansions is what is known as Pascal's triangle. Okay, Pascal's triangle is very easy to form, and what Pascal's triangle gives us are the coefficients. Okay, so it tells us what the coefficients are, and then the variables a and b, there's a specific way to substitute them, so it's very easy to do. Now Pascal's triangle, very easy to calculate. You start with a 1 at the very top, and then there's a 1 and a 1. Now what you do is, to get to the next level, you always add the numbers that are next to each other. So here, I started with 1. There's nothing next to 1. So I say 1 plus 0, and then I got 1. And then the same thing, there's nothing on this side of 1, so it's 1 plus 0, and that is why I also got 1. Now to get the next one on the left of 0, I ask on the left of 1, I say 1, what is on the left of 1? There's nothing, so I put a 1 over there. Then here, what is on the right of this 1? I say 1 plus 1 is 2. And what is on the right of this 1 is nothing, so it's 1. Then I continue in this way. 1 plus 0, this gives me 1. Okay, and then 1 plus 2, this gives me 3. 2 plus 1, this gives me 3. And then 1 plus 0 gives me 1. So already you can see I'm forming a triangle. That's why it's called Pascal's triangle. Okay, then I can continue. I have 1, which is 1 plus 0, and then 1 plus 3, this is 4. 3 plus 3, this gives me 6. 3 plus 1, this gives me 4. And then 1 plus 0, this gives me 1. Let's do one more. So I have 1, which is 1, this one here. There's nothing on its left, so this gives me 1. And then here I will have 5. Then I have 10. Here I have 10, 5, and 1. Now what is special about these numbers, like I said, is that they are the coefficients in your expansion. Now their coefficients, you get this one when n is equal to 0. So that means you have a binomial like this. A plus b is equal to 0. We know that anything to the power of 0 except 0 is equal to 1. So you'll only be left with a 1. This is when n is equal to 1. So if I have a plus b to the power of 1, the coefficients, I will have 1a plus 1b, which is just a and b. This one is when n is equal to 2. So the way that works is I have a plus b to the power of 2. So I write down my coefficients. I look at my triangle, the coefficients are 1, 2, and 1. So I write 1, 2, and 1. Now what happens? Let me just write it below so I have enough space. Okay, so my coefficients, I said, are 1, 2, and 1. Now what happens is the powers of a, the first term, are decreasing. They start here at 2, and then they keep decreasing by 1. And then the powers of b are increasing. They start from 0, go all the way up until 2. So I start with a squared, b, 0, I'm adding. Then a to the power of 1, b to the power of 1, and then I have 1, a to the power of 0, b to the power of 2. So notice the powers of a are decreasing. I have a to the power of 2, a to the power of 1, a to the power of 0. The powers of b are increasing. b to the power of 0, b to the power of 1, and b to the power of 2. So I can rewrite this so it looks better. This is just a squared, and we know that b to the power of 0 is equal to 1. Then I have 2ab, and then I have b to the power of 2. And I'm sure you can tell that that is indeed the expansion of a plus b to the power of 2. Okay, so if you know the coefficients, you just put a and b multiplying together, where the powers of a are decreasing, the powers of b are decreasing. Powers of a are increasing, powers of a are decreasing, powers of b are increasing. Yeah. And then this one is when n is equal to 3. So let's look at a quick example of that. Let's say I ask you, what is 1 plus x to the power of 3? Now you know what the coefficients are. It is 1, 3, 3, and 1 from the Pascal's triangle. Now you just need to say this is my a, and then this is my b. So I should have written this in black. Okay, so this is the question I have, and just like that, just right over it. Okay, so I just need to say this is my a, and then that is my b. So the first one over here, this is going to be my a, and then this one over here, this is going to be my b. And I know that the exponents, the coefficients are just 1, 3, 3, and 1. These coefficients, I get them from the triangle. So I look at my n. My n over here is 3. So I go to the level on the triangle that is 3. So I start with n is 0, n is 1, n is 2, and n is 3. So I take the coefficients in that line, or on that level. Okay, then I have to go to my binomial. Remember, binomial is 2 terms. It must be 2 terms. It doesn't apply. It's not the same as when you have 3 terms. So if you have 3 terms and you still want to use this, you need to rewrite it so that your trinomial or whatever you have is a binomial. So what I mean by that, so this is by the way. Okay, let's say I have 1 plus x plus y, and then I say to the power of 3, and I still want to use the binomial theorem. What I need to do, what I can do is instead write it like this. This is 1 plus x plus y. This is to the power of 3. So now it is a binomial in that this is my a, and then x plus y is my b. Or I could say 1 plus x. So I could say this is my a, and then that is my b. As long as it's 2 separate terms, then it's fine. Okay, so you can still use this in the test. When you see 3 or 4 terms, don't think it's no longer a binomial. You can rewrite it as a binomial. Okay, so let's go back to this one. So I have said this is on level 3. So my coefficients are 1, 3, 3, and 1. And I've identified my a and b. A is 1, b is x, or x is b. Now I will just substitute them in there. So what I have is 1 a to the power of 3, and then x to the power of 0. Then 3 a to the power of 2, x to the power of 1, and then I have 3 a to the power of 1, x to the power of 2, and then the last one I have 1 a to the power of 0, and then x to the power of 3. Okay, so you can see my coefficients. There they are. It's 1. I have 3, 3, and 1. Then if you look at the coefficients of x, those 3, 2, 1, 0. And then the coefficients, the exponents. The exponents of x, 0, 1, 2, and 3. Okay, so you just have to keep with that pattern. Then you simplify. Then what you have is a to the power of 3 plus 3a squared x plus 3ax squared plus x to the power of 3. Okay, so that is your final expansion. So nothing very difficult about that one. Okay, I can look at another one. What if I have x squared minus y to the power of 4? Now here I will still go to my triangle. Level 4 is this one over here. This is when n is equal to 4. Okay, so my coefficients are 1, 4, 6, 4, 1. And then the powers of A are decreasing and the powers of B are increasing, just like that. Okay, so I need to identify what my A and B are. So this first term, this is my A. So I have A is equal to x squared. And then my B is going to be negative y. So it's not just y, it is negative y. Because if you remember, our binomial is a sum. It's A plus B to the power of n. Okay, so if I have A minus B to the power of n, I must rewrite it as a sum. So this is A plus negative B to the power of n. So this is my A, and then in this case, minus B is your B. Okay, this is n. All right, so I have my A and my B, and then I know the coefficients. We said it's 1, 4, 6, 4, and 1. Now I just substitute everything. Powers of A are decreasing, powers of B are increasing. So I have 1, this is x squared, that is my A, and then I raise it to the power of 4. Then my B, this is minus y to the power of 0. Then the next one, the coefficient, we said is 4. So I have 4 x squared to the power of 3, and then minus y to the power of 1. Then the next coefficient was 6. Then I have x squared to the power of 2, and then negative y to the power of 2. Then I have 4 x squared to the power of 1 minus y to the power of 3. And the last one, I have 1 x squared to the power of 0, and then minus y to the power of 4. Okay, so let's just go over that. So you can see my coefficients. I have 1, 4, 6, 4, and 1. Okay, those coefficients, I got them from level 4 on the Pascal's triangle. So to know what level I need to use on the Pascal's triangle, I look at the coefficient over here, the exponent. I look at the exponent 4, and that tells me what level I am on in the triangle. And then you identify your A and B. Then the powers of A are decreasing, so it's 4, 3, 2, 1, and 0. And then the exponents of B, which is minus y, are increasing. So I have 0, 1, 2, 3, 4. Now you'll notice that the powers of A and B, when you add them, they always add up to the exponent that you have here. So this exponent I have is 4. Then here I have 4, 0, 3, 1, 2, 2, 1, 3, 0, 4. Okay, then now I simplify, and let us do that. Okay, so for the first one, I have 1 times x squared to the power of 4. That is just x to the power of 8. Y to the power of 0 is just 1, so I don't need to write that one. Then next I have 4 times x, so the 4 is the only constant, 4, and then x squared to the power of 3, that is x to the power of 6. And then I have minus y to the power of 1, which is minus y. So that minus will come in, well, let me just write it, then we'll simplify again. So it's minus y. So this minus over here will come and change this plus that I have over there. Then the next one, I have 6 x squared squared. This is x to the power of 4. And then minus y squared, that is just y squared, because the negative times the negative gives me a positive. So I will just have y squared. And then the next one, coefficient is 4. Then I have x squared to the power of 1, which is just x squared. And then I have negative y to the power of 3. This is just negative y to the power of 3. Because there are 3 negatives, I will end up with a negative answer. And then the last one, I have negative, I have 1 times x squared to the power of 0. X squared to the power of 0 is just 1. And then negative y to the power of 4. There are 4 negatives. They'll cancel each other out. And then I will just be left with a positive y to the power of 4. Then I'm going to simplify these negatives that I have over there. Then I should have this x to the power of 8 plus 4, still writing plus, minus 4 x to the power of 6y plus 6 x to the power of 4 y squared minus 4 x squared y cubed, and then plus y to the power of 4. So again, it's always good to check your working, make sure that it is correctly done, especially when you have those plus and minus terms. It can be a little bit tricky. Let us do just one more very quickly. Let's say I have x minus 1 over x to the power of 3. So again, I will use my Pascal's triangle, and I'm using level 3 because the exponent over here is 3. So my coefficients are going to be 1, 3, 3, and 1. Okay. Then I need to identify my a and b. So a here will just be x, and then b is going to be 1 over x. That is negative because the sign over there is negative. Then you just substitute. So I start with 1. Then this is x to the power of 3. And then I have minus 1 over x to the power of 0. And then plus 3 times x to the power of 2 minus 1 over x to the power of 1 plus 3 x to the power of 1 times minus 1 over x to the power of 2, then plus 1 x to the power of 0, and then I have 1 over x to the power of 3. Okay, then I simplify as far as possible. Okay, so for the first one, I will just have x to the power of 3 because this is equal to, you can see this over here, it is raised to the power of 0, so that's just equal to 1. And then for the second one, I will have 3 times x squared times minus 1 over x. Now you'll notice that the 1 over x and the x squared, so here this and that one, some cancellation will take place, and what you will actually have is negative 3x. So you multiply them, the x squared multiplied by negative 1 over x, so it's negative, and then x squared divided by x, that gives me just x. Then the next one, I have 3, and then this x, when I divide it by x squared, this is positive because I'm squaring this, so it's negative times negative, so the negative sign will disappear, so I will be left with 3 over x. And then for the last term, I will have 1 negative. So there's a negative sign over there. So the last sign is negative 1 over x to the power of 3. Okay, so that is the expansion. Now, depending on what your exponent is, you'll notice that there may be some points where x is gone. Okay, so that is possible. You might have something like this, let's say 2x plus y. Then when you multiply this out like this, remember that the 2, the exponent over there, this is to the power of 2. The exponent also affects the 2. So the coefficients also play a role in that. Now, next thing we look at is what to do when you have something like this, a plus b to the power of minus 2. Okay, now this one, obviously we cannot use Pascal's triangle because Pascal's triangle has levels 0, 1, 2, only whole numbers. Now it is possible to expand this, but you cannot use Pascal's triangle. Now what you can do is actually use long division. Okay, so it might seem a little bit tricky, but the procedure of long division is exactly the same. Now this x plus b to the power of minus 2, you can rewrite it as 1 over a plus b squared. Okay, then I do long division the way I normally do. This is just 1 over squared plus 2ab plus b squared. So we can use Pascal's triangle there, but we're not done. So long division, I have a squared plus 2ab plus b squared, and then I put my 1 over there. And then I do the division the way I normally do. I would always say whatever I have here divided by the first term, I write the answer over there, then I multiply that with this one, put it there, multiply that with this one, put it there, and then I subtract. So I'm going to do the same thing, nothing is different. So I say 1 divided by x squared, this is just 1 over x squared, a squared. And then when I put the a squared over there, now I multiply. So I'm going to shift it a little bit this way so we have some space, but in your notes you can write everything nicely aligned. Okay, so 1 over a squared times a, so now I'm multiplying. So first procedure was this one, divide it, write it over there. Once it's written over there, then you multiply all the terms by whatever you wrote up there. So when I do the multiplication, I will get 1. And then I have 1 over a squared times 2ab. Notice that the a squared will cancel with the a. I will be left with 1a in the denominator. So this is 2, which is in the numerator. There is no a in the numerator anymore, but I have b over a. Okay, so what I'm doing is this. 2ab times 1 over a squared. So this cancels a, that is 1, so I have 2b over a. So that's how I got that one. And then I do the same thing with the b squared times 1 over a. That one is simple to do. This is just plus b squared over a squared. And then as usual, I just subtract. So I say the 1 minus 1 is 0. And then there's a 0 minus 2ba. This is just minus 2ba, b over a. So again, I'm shifting it to the left so that I have space. You know how to write this. You would write it over there. So I'm just trying to use the space that I have. And then I will have minus b squared over a squared. Then I continue in the same way. I say this term that I have over there. So let me write it here. So I have minus 2b over a, and then I divide this by a squared. This is the same as 2b over a times 1 over a squared, and this is just equal to 2b over a to the power of 3. Then when I have this, I always write it on top. Okay, so I write it over there, and this is negative 2b over a to the power of 3. So it's negative because this is negative. So I didn't write the negative over there, but it should be negative. And then after I've written it on top, I follow the same procedure. I multiply what I wrote on top with all these terms. So again, I will say this term here multiplied by the a squared. That gives me minus 2b over a. And then 2b over a cubed times that one. So you know how to do the division. The multiplication. So the 2 will multiply with the 2. So it's negative again. I get 4. And then the a will cancel with the a cubed. So I'll be left with a squared in the denominator. And then the b will multiply with the b. So this b multiplies with that b. I get b squared. So this is b squared. And then the same thing with b squared multiplying with this term. So it'll be 2. The b squared times the b is b to the power of 3. And then this will be over a to the power of 3. So it's still negative 2b cubed over a cubed, like that. And then you do the subtraction again. Okay. So the first term will obviously be 0. So I have negative 2b over a minus negative 2b over a, that is 0. Then for this one here, this is b squared over a, and that one is also b squared over a. This is negative 1. So I say negative 1b squared over a minus negative 4b squared over a. That should give me 3. Okay, so it's negative this, and then I subtract negative 4. So I'm saying how many b squareds over a do I have? I will have positive 3 of them. So again, for alignment, I just write it over here. So 3 over a squared. And then negative of that one, I get 2b to the power of 3 over a to the power of 3. Now notice this is never ending. You can just keep going on, and then you never stop. So this division over here, if I were to write it, or this expansion rather, this is a plus b to the power of minus 2. This is just equal to, so I take the terms that I have on top over here, like I did with my partial fractions. So this is 1 over a squared minus 2b over a cubed. and then you can continue in that manner. So it depends on how many terms I ask you for. So if I ask you for 3 terms, then you must do the division one more time. So you'll say this divided by a to the power of 2. You write the term over there. Okay, so that is how we would do it. Now this expansion, it has a restriction in that we need the absolute value of b to be less than the absolute value of a. Okay, so when your exponent is not a positive integer, okay, or it's not 0, it's anything to the power of 0 is just equal to 1, then there are some restrictions that we will apply, and we'll see how to do those ones. Okay, so this is the restriction that we have, that the absolute value of b must be less than the absolute value of a. So that's the only thing. If it is an integer, there are no restrictions. If it is not a positive integer, then there are some restrictions that we will do. Now this long division, as you can see, it is quite tedious. There's a lot to do. Very easy to make a mistake. Now binomial theorem is an easier way of doing the long division. Okay, so here there is a formula of how to do it. Now if you have a binomial, okay, now this is the binomial formula itself. Binomial. Okay, so this is just a shorter way of doing it. So when I ask you for 4 terms, instead of doing the long division, you can use a formula to just substitute your values, and then you will get 4 terms or 5 terms or however many terms you're asked to give. So if I have a plus b to the power of n. Okay, now this is a binomial because I have 2 terms that I'm adding, a and b, and then my exponent over here is n. Now the binomial theorem works whether you have n is a positive integer or any other real number. Okay, it works. Pascal's triangle, you must have 0 or a positive integer. So this one works for whatever you have. Now the way the formula goes is the first term is just a to the power of n. Then the n will come down, and then the power of a decreases by 1, so I have n minus 1, and then b has a power of 1. Then the next one, the n was already down. Now this n minus 1 is also going to come down, and the 2 of them will multiply. So I have n times n minus 1, and then I have a to the power of n minus 2. So the powers of a are just decreasing by 1. So I started with a to the power of n, a to the power of n minus 1, a to the power of n minus 2, and then I have b to the power of 2. So the powers of b are increasing by 1. So here I have b to the power of 0. b to the power of 0 is 1. Okay, so I didn't need to write it. Then b to the power of 1, b to the power of 2. Now with this one, I will divide by 2 factorial. This one here, you can divide it by 1 factorial, but 1 factorial is just equal to 1. Now factorial means this. So this is by the way. So n factorial, this is equal to n times n minus 1 times n minus 2, and then you go on until you get to 1. So factorial is a mathematical function that you perform on positive integers. So if, for example, I have 5 factorial, this is 5 times 4 times 3 times 2 times 1. Okay, and then you work it out on your calculator. 5 factorial, this is equal to 120. Okay, the exclamation mark symbol on your calculator means factorial. Okay, so you start with your n, then you multiply it with n minus 1, n minus 2, n minus 3, and so on until you get to 1. Now 0 factorial, this is just equal to 1. That's a definition. And then 1 factorial is also just equal to 1. Okay, so if you didn't know that already, there it is. Now, this continues in the same way like that. So I would have n minus 1, n minus 2, and then I have a n minus 3, b to the power of 3, and then I divide by 3 factorial. And I must continue in that exact same way, okay, until I have as many terms as I was asked to find. Now you'll notice with an integer, if I have an integer, let's say for example this was 5, eventually I would get 5 minus 5, and then when I bring down the 5 minus 5 I get 0. So all the terms after that will just terminate, and I have the same results as with Pascal's triangle. But when I have an exponent like minus 2, like I did over there, you will notice that minus 2, if I keep subtracting 1, I will never get to 0. So I will always have terms. So I can have 1,000 terms, I can have 1,000,000 terms. The terms never finish. So it is an infinite series. So what we can do, since time is up and I have another class, I would like for you guys to try this, the same one that we did, a plus b to the power of minus 2. Use Pascal's triangle. Not Pascal's triangle, use the binomial theorem. Now, after you use the theorem, you must keep in mind that because this term over here is not a positive integer, there are restrictions. So when you're done, you will just say restrictions. I think we can just quickly do it. Let's do it. Okay, so the formula says the first one, I have a to the power of minus 2. Then the second term, the minus 2 must come down. So I have minus 2. Then I have a to the power of minus 2 minus 1. This is minus 3. And then I have b to the power of 1. Okay, so remember I'm dividing here by 0 factorial. So 1 factorial. So if you're going to forget where the 2 factorial starts, it's best to, from the beginning, put the 0 factorial, 1 factorial, and so on. And then I continue. So now this minus 3 is the one that will come down. So I have minus 2, minus 3, a to the power of minus 4, and then I have b to the power of 2, and then I divide this by 2 factorial. Okay, then I can do one more. I have minus 2, minus 3, the minus 4 comes down now, minus 4, and then I have a to the power of minus 5, and then b to the power of 3, and then divide by 3 factorial. So here I put plus dot dot to show that it continues. It doesn't just stop with the terms that I have. And then we simplify it and see if we get the same answer as when we did long division. So for the first one, I have a to the power of minus 2 divided by 0 factorial. Remember, 0 factorial is equal to 1. So for the first one, I have 1 over a squared. So I have 1 over a squared. And then for the second one, I have minus 2 a to the power of minus 2. So this is minus 2 b. That's going to be in the numerator. And then I have a to the power of minus 3. Okay, so that's what I have over there. So with our long division, we worked out 2 terms. So let's compare those 2 and see if they're the same. So you can see over here, they're already the same. Okay, so the terms that I would have gotten had I continued over here, I very easily get them by using the binomial theorem. So let me continue. For the next one, it's this one over here. So I say minus 2 times minus 3, that is 6, and then I will divide that by 2 factorial. 2 factorial is just 2, so I will have 3. So this is positive. So I have plus 3, and then b squared is in the numerator, and then in the denominator I have a to the power of 4, like that. And then the fourth term over here, I have minus 2 times 3 times minus 3 times minus 4. That gives me 24, and then I divide that by 3 factorial. 3 factorial is 6, because it's 3 times 2 times 1, which is just 6. So 24 divided by 6, I get 4. And my answer is negative, because I have negative, negative, negative. 3 negatives make a negative. So I have negative 4. In the numerator, I will have b to the power of 3. And then in the denominator, I have a to the power of 5. And then I say dot, dot, dot. Okay, so you can see me getting 4 terms using the binomial expansion is much easier than me getting 4 terms using long division. Now here again, because my exponent was negative, I have to put a restriction. So the restriction is the absolute value of b must be less than the absolute value of a. So that's your restriction. Whatever you have, you see, in this case, my a and b were just a and b themselves, but we did questions where a and b were not a and b. We did this one, for example, where a is x and b is 1 over x. So you just substitute them over here. So with that question, you would say b, the absolute value of x must be less than the absolute value of minus 1 over x, for example. Okay, so I will stop here for now. We're pretty much done with the binomial expansion, because that is it. It's just about using this formula that I've given you over here. So you just need to remember the formula, and whatever you are given here, it doesn't matter whether it is a positive integer or it is a fraction, you still use it in the same way. If it is an integer positive, you can use Pascal's triangle, but for numbers like 10, that drawing the Pascal's triangle up to 10 can still be tedious, even though it's easier than multiplying out the brackets. So do we have any questions, comments? Okay, if not, remember that the test tomorrow, we start at 1800 hours. Please make sure you have a scanning app. I prefer Adobe Scan. It's free. You just take a picture, it converts it to a scan. All the instructions will be given to you soon. Okay, so if there's nothing else, then I will see you guys tomorrow at 7:30.